Hey everyone, and welcome back to Emerge Tech AI Tool Talks, the podcast where we dive deep into the cutting edge tools and techniques shaping the world of AI. I'm Brian, and today we're zooming in on a fascinating concept that's revolutionizing how AI perceives and interacts with the visual world: spatial attention. Spatial attention in artificial intelligence refers to mechanisms that focus on specific spatial regions in an input, e.g., an image or video, to extract or process information more effectively. It mimics how humans selectively pay attention to different parts of their visual field to prioritize relevant information. Spatial attention is commonly used in tasks like image classification, object detection, semantic segmentation, and video processing. But why is spatial attention so important? Well, it helps highlighting important regions in the input, reducing noise from irrelevant areas, improving the interpretability of AI models. Now, let's explore some of the leading spatial attention models making waves in the AI landscape. First up, we have attention mechanisms within convolutional neural networks, or CNNs. Senet, Squeeze-in excitation network, introduces channel-wise attention, but often works in tandem with spatial attention. Highlights important spatial regions indirectly by modulating channels. CBM, Convolutional Block Attention Module, combines channel and spatial attention to enhance feature representation. Lightweight and effective for object detection and segmentation tasks. It's open source, so you can experiment with it yourself. You can find it on the CBM GitHub repository. Next, we have the rising stars of AI architecture, Vision Transformers, or VITs. These models are shaking up the scene with their ability to capture long-range dependencies in images. DTAR, Detection Transformer, combines spatial attention with transformer-based architectures for object detection. Directly models object relationships in space using attention mechanisms. And yes, it's also open source. DTR GitHub. Now, let's not forget some of the other heavy hitters in the spatial attention arena. Spatial Transformer Networks, STNs, explicitly focuses on spatial transformations like rotation, scaling, and cropping to align inputs. Allows models to process spatial regions effectively without explicit pre-processing. And yes, it's also open source, STN PyTorch implementation. YOLO, You Only Look Once, series, leverages spatial attention implicitly in its detection pipeline. The latest versions, e.g., YLOV7, incorporate spatial attention modules for enhanced detection accuracy. And yes, it also open source, YOLO GitHub. MaskRCNN uses spatial attention to focus on regions of interest, ROIs, for instance segmentation. Combines spatial attention with feature maps to refine predictions. And yes, it's also open source, MaskRCNN GitHub. SAN, Spatial Attention Network, fully focuses on spatial attention without channel attention. Tailored for tasks where spatial relationships are critical. Open source. Partially, implementations exist, but are not official. UNet with attention mechanisms adds spatial attention for semantic segmentation in medical imaging and other domains. Enhances the focus on important spatial regions and images. Explore the Attention UNet GitHub repository for open source implementations. Open source models with spatial attention. CBM, GitHub repository for plug-and-play spatial and channel attention. DTAR, transformer-based object detection. YOLO, integrates spatial attention into object detection pipelines. MaskRCNN, for spatial region-focused segmentation. Spatial Transformer Networks, PyTorch, and TensorFlow implementations. Attention UNet, widely used in segmentation with spatial modules. The applications of spatial attention are truly vast and span across various domains. Use cases of spatial attention: computer vision, object detection, image segmentation, action recognition, medical imaging, highlighting areas of interest in MRI scans or X-rays, robotics, navigation, and object manipulation based on spatial awareness. Augmented reality AR, tracking and analyzing spatial objects. Spatial attention continues to evolve, driven by advancements in vision transformers and hybrid attention mechanisms. Open source implementations make it easier for developers to integrate these techniques into real-world applications. And that brings us to the end of today's deep dive into spatial attention. It's an exciting field with immense potential, and with open source tools readily available, you can start experimenting and building your own spatial attention-powered applications today. Thanks for tuning in to Emerge Tech AI Tool Talks. If you enjoyed this episode, be sure to subscribe, leave a review, and share it with your fellow AI enthusiasts. Until next time, keep exploring the fascinating world of AI.